Please, camera fictions.
Thank you. So we are, as we've been doing for the last few days, we're going to continue our discussion on factoring. Again, we are still in. So guys in the back table, we are still talking about parabolas, right? How do you know when something is a parabola? When an equation is a parabola? Does anybody know? We haven't really talked about it yet. But it has to have an x squared in it, okay? For it to be a parabola. Like y equals x squared is a parabola. If I drew that out, if I did my t-chart, I could plot it, and it would sure enough give me a parabola. A happy face parabola, okay?
Yay!
And so that's what we're talking about. All of these things we're talking about with factoring, with the exception of some of the polynomials where I just did randomly wild things like 5x to the 9th, y to the 7th, right? That's not, we're not talking about parabolas there, we're talking about polynomials, but not parabolas. But we still use that concept of factoring out the greatest common factor when we're dealing with parabolas, as we did with polynomials. Yes?
How do you graph like something that's squared? Like with x squared?
Well, that's a good question. This isn't the lecture, but that's okay. I'll show it to you really fast. Y is equal to x squared. Well, you probably all have learned, well, I'm sure you have, like using a t-chart, right? A t-chart, right? Where this is your x and this is your y, right? And you choose your x's that you like, and then you figure out what your y is when x is this, right? You've done this. That's how you first learned to graph, right? Right? So let's say x is 0. What is 0 squared? 0. All right, let's say x is 1. What is y? 1 times 1 is 1. Let's say x is 2. What's y?
4.
4. Let's say x is 3. 9. Okay. Let's say x is negative 1.
1.
1. Let's say it's negative 2. 4. Negative 3. 9. That's interesting. Notice that 1, when x is positive 1, y is positive 1. When x is negative 1, y is also positive 1. When x is positive 2, y is positive 4. When x is negative 2, y is positive 4. That's what makes it turn around, right? So if I were going to plot this on a graph, this is really not what we're talking about, but that's okay. It's kind of fun anyway. We will be doing this fairly soon, right? So I have my graph here. I guess that's as far as I need. So 0, 0 is right here. 1, 1 is right here. Negative 1, 1 is right here. 2, 4 is right here, sorry. And negative 2, 4 is right here. And 3, 9 is somewhere up here, right? And negative 3, 9 is somewhere up here. So then it gives you this parabola. And it's because of that squared there. It's y equals x squared. The x squared makes y always positive, because no matter whether x is positive or negative, it flips it around, right? See what I'm saying?
Yes.
And that's why you get the parabola. So those are the kinds of things that we're actually dealing with when we're talking about this factoring. Everything I'm doing from now on is going to be related to parabolas, okay? So we don't need that right now, but that was a good question. So we have talked about factoring simple quadratic trinomials, right? And we know when you do simple, what did I just say? Simple quadratic trinomials, right? Simple means, well,
it means it's not really simple.
we know simple. I'll just write it here. Simple quadratic trinomials.
Gary, how would this be useful anyway?
Parabola.
It's actually, ironically, very useful if you want to know certain things. But, I mean, if you wanted to know how long, if you drop something out of a plane, and you want to know how long it's going to take to land on the ground, you know, then this will help. It will also help you calculate speed, right? Well, sort of. you need something else for that reason. But to figure out time, the amount of time it would take for something to fall from above and land on the ground, that could be very useful, right? If you wanted to calculate, if you were an architect and you're designing a bridge, and you want to be sure the bridge has a basic parabolic slope to it, right? So you would figure out what is that parabolic slope to it, and then you have to have these stands. You want to be sure that the sailboat that has a mast that goes, 57 feet high, you want to be sure that sailboat can go under that bridge. It'd be a real bummer if you made it for that sailboat and the bridge only allowed it to go if it was 53 feet high, right? That'd be a real bummer because you'd spend millions of dollars making the bridge and then it wouldn't work, right? There's lots of things that you can use. I've got tons of word problems that we're going to eventually start doing to understand how this stuff works. But for now, I'm only teaching you the tools because you can't do the word problems until you know the tools. So you have to know how to factor simple quadratic trinomials, which you now do, right? What are you looking for when you're trying to factor simple quadratic trinomials? That would be something like ax squared plus bx plus c. So I'm looking for factors.
You would find the factors of c.
Add up to b.
That add to b, right? Good. And everybody gets that, right? Adds to b. Factors of c that adds to b. Okay. Now, why would I say simple again? What makes it a simple quadratic?
A equals 1.
A and A, yes, this A is equal to 1. Now, what makes it quadratic?
X squared.
Yes, the x squared is what makes it quadratic. Quadratic means it's a parabola. Okay? Okay? So there's a lot that statement says. Simple means A is 1. Quadratic means it's x squared. And trinomial means there's 3 terms, right? Okay? So that's really awesome. Now, sometimes, though, you won't have 3 terms. You will have 2 terms. Now, let's look at the title of the lecture. It says factoring difference of 2 squares. Okay, we know what factoring is, right? 2 numbers that, or any 2 numbers that multiply to equal another number, right? Those are the factors, right? The numbers you multiply times each other. What's the difference mean?
Oh, it's when you subtract, it's the answer.
Is he right? Difference is always subtract?
Yeah.
Are you sure?
Yeah.
You're positive?
No, we're negative.
Right. Ooh, very good. All right. So if I woke up this morning and it's 100 degrees out, and right now it's 60 degrees out, what's the difference? 40 degrees. What did you do to get that? You subtracted. So difference always means subtract. So if it says factoring difference of 2 squares, there's got to be a negative sign in there. Don't you agree with me?
Yeah.
You're going to have something here and something here and a negative sign in between. Has to be a negative sign. Now, what's the next thing it says? It says 2 squares. What's a square? Michael. What?
A number times itself.
Okay, a number times itself, right? Like, so x squared would be x times x, right?
Yeah.
So that is a square, right? 8 times 8 is 64, right? 8 times 8, those are factors of a square that is 64, right? 64 is the square, and the 2 sides of the square are 8 times 8, right? You guys with me?
Yeah.
Okay. So what if I gave you a problem like this? What if I gave you x squared minus 64? And I asked you to factor it. Factoring it would mean it would look like this. Okay? Now, is that a binomial or a trinomial?
Binomial.
It's a binomial, and it is actually also a hidden trinomial. Why would it be a hidden trinomial? Why would I say that? Yes, Mike. No, this is still one term. A trinomial means a term like,
That adds.
yeah,
Yeah.
right? So this is, it means you have three terms. A trinomial means you have three terms. This is one term, then and terms are separated by pluses and minuses. And why would I ever, in my right mind, say that this could be thought of as a trinomial?
Because there's like plus 0 or something?
Yeah.
Ah, so what is a quadratic equation, quadratic expression? The full expression is up here. Ax squared plus bx plus c. What are we missing in this equation?
Something else.
We are missing x and c.
We're missing the bx, right?
Yeah.
Don't you agree? Everybody agrees? The x squared is there, x squared, and the c doesn't have an x after it, so that the 64 has to be c, right? So we're missing. So technically, I'm not always going to write it like this, but I just want you to see. Technically, what this is really stating is this: x squared plus how many b's? 0 b's, right? Minus 64. So if I was going to factor this, what would it be? Using this method, you know how to do it. Factors of c that add to b. So Michael, what would it be?
It'd be x plus 8 and x minus 8.
Does everybody agree with him?
Yeah.
X plus 8 times x minus 8. That's interesting. Now, are we sure that's going to get rid of our middle term and make it a 0?
Yeah.
Let's try it. Let's try our outside plus our inside, right? Outside is negative 8x, inside is positive 8x. 8x minus 8x is 0. So I have 0 x's, therefore this is what I get. X squared minus 64. Now there is a actual rule. You don't even need the rule because you already know how to do it. Based on, once you realize this is a quadratic, and you can think of it as a trinomial, even though it doesn't have the 3 terms in it, you can realize, oh, the reason it doesn't have the third term is because the third term is 0, right? So that's good. So you already know how to do it. But here's a rule to follow for difference of two squares. Usually you'll see it like this. A squared minus b squared is equal to parenthesis a plus b times parenthesis a minus b. Is that on the thing? Does that make sense? So technically, if I was going to use that rule for this, I've got x squared minus 64, right? But I have to have a b that's squared to get 64. And Michael said it was 8. 8 squared is 64. So instead of writing 64, I could write x squared minus 8 squared, right? Equals x plus 8 times x minus 8. Does that make sense? X plus 8 times x minus 8. Another way to think about it is this number is going to be the square root of this. This number is going to be the square root of this, right? See what I'm saying? So let's do a few examples. So, where are we? I guess I'll
So
start here.
it's basically like the same way to do it.
Yeah.
I like the one that you did.
You like which way?
The first one.
This way?
Yes.
Yeah. So, but this is, all this is, I don't usually do this. I don't think of it as 8 squared. I just think of it as 64. This is how I think of it. But the way I just showed you is the way this thing is written, right? But really, I know that this is the square root of this, right? And I know that this is the square root of this. So, square root of x squared is x. The square root of 64 is 8. So it's x plus 8 times x minus 8. The only way I can get a negative 64 is going to be if they're both opposite signs, right? The numbers have to be exactly the same numbers for them to come out as a 0 in the middle. Is that clear? You see that? See that? Yes.
What happens if the, like, there's 64 there, but what happens if it's like 66? It doesn't have like a
That's a really good question. So let's try that. Let's say we had x squared minus 66. Now notice it has to be minus because we're talking about difference of two squares, right? Now, x squared is a perfect square, right? 66 technically is not a perfect square. It doesn't come out as an even number. but it still has a square root. Would you agree with me?
So would you just put it like x times the square root of 66?
I would do it like this. I would go like this. I think this is what you meant.
Yeah,
X
that's what I
plus
meant.
the square root of 66 times x minus the square root of 66, right? Since I can't, it doesn't have a perfect square, that's going to go on forever and ever and ever probably, right? And so if it's going on forever and ever and ever, I don't want to go on forever. I mean, I want to go on forever and ever and ever, but not doing that, right? I'd rather be sailing forever and ever and ever, right? Well, no, I don't know. That's another That's another subject. Maybe tomorrow we'll cover what I would do forever and ever and ever. But
Yeah.
today is just factoring the difference of two squares.
Tomorrow,
Okay.
Saturday, I mean, no.
But does that make
No, we
sense?
should just
Do you guys see this? Does that make
take
sense
off.
to you?
Yes.
Right?
Yeah.
That's accurate. That is accurate. And sometimes as we move forward into these quadratics, you will see things like this, right? Okay, so that's that. So let's try a few.
Here, you should make tomorrow's lecture about the most difficult part of algebra.
X squared minus 49. What would that be?
7.
So it'll be
It'd be x plus 7 and x minus 7.
Right, beautiful, beautiful. Okay, number 1, 2, 3. Number 3. How about x squared minus 144?
It'll be
Oh, 12.
X
12.
plus
It's 12.
So it'd be x plus 12 times x minus 12, right? All right, how about this? I'm going to throw a little curveball in. What if I gave you, let me think about this for 1 second. How about I give you 4x squared minus 25. Yeah, Lila?
Would it be 2x plus 5 and 2x minus 3?
What do you think? Does that make sense?
Yeah.
So she's saying take the square root of this whole thing. The square root of 4 is 2. The square root of x squared is x. That sounds like it might work. Let's try it. 2x, because the square root of 4 is 2, square root of x squared is x, plus square root of 25 is 5, times 2x minus 5. Remember, what you see in these two have to be identical, except for the signs, right? The plus and the minus. They have to be different, right? And that works. Outside, well, first of all, FOIL, first. 2x times 2x is 4x squared, all right? Outside is 2x times negative 5, negative 10x. Inside is positive 10x. There's my 0 x's. And then negative 25. Bullseye. Well done. Yes?
What would happen if it was like 7x squared minus 25?
Okay. Well, let me do a different one. Well, I'll do that one. That's okay. Let me just erase a little bit here. That most math teachers aren't going to give you that because all of us math teachers love everything to work out and love you to, whatever. But that's okay. Let's try it. If I gave you this, what did you say? 7x squared minus 25.
Yeah. No.
All right. So x squared and 25 are both perfect squares, but the 7 isn't, right? So you see how that's the problem, right? I think if it were me, if I had to factor it into two different, difference of two squares method, I would say the square root of 7x plus 5, right? You see what I'm saying? Or usually you put the x in front of your square root, right? So I'd do x squared is 7 plus 5 times x squared is 7 minus 5, right? If I had to factor it. But you're not likely to get, I'm never going to give you one of those intentionally, right? But it makes sense, right? It's not rocket science, right? Makes sense?
Yeah.
Right? You got to do the square root of whatever this term is, plus the square root of this, and then the square root of this term minus the square root of this, if you're going to factor it, right? Okay, so, but what if you got something like this? back in, okay, what if I gave you this? 4x squared minus 16.
Hello?
Oh my god.
Is that over on?
I have no on.
Yeah, remember?
Over on?
Oberon.
Oberon.
Remember the things we
Under.
did?
Very king.
And then is that
Okay.
Oberon?
Okay.
Alright, so,
Yeah, let me put my
Okay.
clothes away.
What should I
okay, back to this. Difference of two squares. Yes.
Okay, it would be 2x.
Alright, so Anna's prediction is she's going to do what we've been talking about. The square root of this plus the square root of this times the square root of this minus the square root of this, right? Is it over already? No way.
No.
No, we're good. Phew. Didn't I just hear a bell?
No, that was your
That was
phone.
Oh, that was my phone. What does that mean on my phone? I don't know what it does.
It's
Email.
That's email?
You got
Okay,
it.
great. Thank you.
Now you know.
Alright.
Okay,
So you see, this is useful. We're learning something here. Okay.
totally.
Alright. So she's saying that it should be this. 2x plus 4. Thank you. I had a little brain fart there. Okay. 2x minus 4. So that's what she says. Is she right?
Of course she is.
She did everything right.
Yes, she is. Right.
But there is an issue. There is an issue. If you notice, the goal with all of these is that when you finish, what is in each binomial has to be fully factored. Could I factor something out of this?
Yes,
Yes.
you could.
What could I factor out of this?
You could factor out the 2.
Okay, so I could factor a 2 out of just this one. So I'm going to do 2 parenthesis x plus 2. Am I right? Okay, but then can I factor something out of this?
Yes, 2.
Okay, so I'm going to put another 2 here, 2 times 2, and just put the x plus x minus 2 here, right?
Okay.
So really, what did I factor out? I factored out a 4. 4 parenthesis x plus 2 times x minus 2. Now, remember my cardinal rule of factoring? Before you do anything, before you jump to this, to difference of two squares, before you jump to, factors of this that add to this, before you do anything, the cardinal rule of factoring is ask yourself, is there a greatest common factor that I can pull out right away? I could have, right. So this I want to factor out right away. So if I was doing this, let me erase this, and let's say I had number 6, right? We're doing 6 all over again.
I know,
My-
you haven't
my-
close it. It's not closed.
My marker is starting to go.
Well, I can't see it.
Gary,
So it doesn't bother
Gary,
me.
Gary, please
Oh
close that
no,
parenthesis.
you don't have to put that parentheses because I can't see it.
Oh, whoa, the pen exploded.
That's no good.
He exploded his pen.
Okay, I got it.
do it.
Hey,
All right.
Gary.
Gary, the pen committed suicide.
Why
Okay.
is it all
You
scratched
broke the
up?
pen.
Oh, I see what's
6
that.
again?
Where are the
Gary.
pens?
Gary, the pen committed suicide and exploded inside.
Okay, throw it away.
But it's so cool.
Okay, guys,
We have
come on,
2
come on.
6s.
I don't want to forget because we're in the middle of this problem. Okay, so I'm going to rewrite this. 4x squared. Where am I? 4x squared minus 16. Okay, guys. Shh. All right. First of all, my cardinal rule of factoring. Is there a greatest common factor that I can factor 4? So I'm going to immediately do that. And then I have x squared minus 4. All right, now I'm ready to factor this.
The pen is falling off.
What will this be? The square root. So I'm going to have, so my answer, I have to keep that 4 there, right? But I'm going to have this, right? And I've got x here, x here. So the square root of x squared is x. The square root of 4 is?
2.
So I do plus 2 and minus 2, right? It's pretty easy, right? That makes sense? You see it? All right. Let me just look at this and make sure I'm not leaving something out. You will sometimes see this. I will sometimes give you something like this. We've already covered it, really. I just want to see. What if I said x squared minus 13? And I asked you to factor out the difference of two squares.
Okay.
Lila.
X squared
Wait.
X plus square root of 13 times X minus square root.
Right, exactly, right? Because 13 doesn't have a perfect square root, but I could still write it because that square root of 13 means whatever the square root of 13 is. That's why you write it. Miracle. Okay, great. So that's pretty easy, right? Pretty straightforward. Let me see if there's any other examples. Oh, interesting. I did one on here. Do you understand why you have to keep this 4 here? Right? Do you all see that? It's still part of the problem. At any time, if I multiply, is that down? All right, at any time, if I multiply everything out, that's got to always equal this, right? If I let go of the 4, just because I factored out, I can't just make it disappear. If I did, if I multiplied that out, it wouldn't give me 4x squared minus 16. It would give me x squared minus 4, right? See what I'm saying? I got to keep that 4 intact, right? Now there is an exception, and that's this is an expression. This is not an equation. What do you need for an equation?
Equal sign.
An equal sign. Let's just say, for just a second, I had this: 4x squared minus 16 equals 0. Now suddenly I have a totally different option. I could factor it out just like this, right?
X equals
And then
2.
say equals 0. But what else
X
could I do?
equals 2.
Immediately, instead of factoring out a 4, I have an equal sign. Remember what's the golden rule of algebra say? Right, whatever you do to one side, you got to do to the other. I could not factor, but I could just divide this by 4. In other words, this by 4, and this by 4, and this by 4. Let's get rid of that. Right? And suddenly, look at this. I have x squared minus 4 equals 0. I got rid of the 4. Is this legal?
Yes.
It's legal. Why is it legal? Why is it legal?
Everything to the other side.
Because I did the same thing to the other side, because I had another side to do it to.
Okay, this is fine.
But if I don't have another side to do it to, it is not legal. You got to leave it. Yes.
At X equals 2. If you equals 2.
Ah, okay. So this is interesting. So how would you solve this? I'm just curious. So
Plus
so
4. Plus 4.
so Ben is saying this. Ben is saying we're going to add 4. So guys, this is not part of the lecture, but what the heck? Let's do it anyway. Right? You guys are amazing. So I'm going to add 4. Add 4. I don't even know if this is on the... Yeah, I think it is. Okay. That doesn't look like a 4.
This is beautiful.
Okay. So we got x squared is equal to 4. What is the answer? How would you find the answer?
You would divide by 2. Divide the x by 4.
What?
Divide by 2. No. No.
Divide by 2?
No. Never mind. If you to cancel out a square, you have to do
The opposite of doing it.
What's the opposite of a square?
A square root.
Right. So the only way I could say this. Look at this. Isn't x squared the same as x times x equals 4? Right? So technically, I could divide both sides by x, right?
No.
And then I get 1x, right? If I divide both sides by x,
Oh yes, but then what?
but then that gives me x is equal to 4 divided by x. That doesn't really help me.
No, but
Right?
x equals 2.
So that didn't work. So let's go back to the drawing board. Somebody was saying the opposite of a square is a square root. So we could take the square root of this side, and we could take the square root of this side. So we have x is equal to
I already said that.
2, or what else?
2.
What else could that be? What else can the square root of 4 be?
What's that for?
2, what else?
What?
2 numbers exactly the same.
Negative 2.
Negative 2 times negative 2 is?
4.
Ah, so this is what? In quadratics, when we're dealing with quadratics, right, the parabolas, when you take the square root of both sides, the square root of this, immediately you have to add something to it. You have to add a plus or a minus. And then you put your 2. Right? That plus or minus is really important. It gives you 2 answers. And that's why you have a parabola. Because there's going to be 2 legs of that parabola, either going up or going down. You're going to have 2 x's, right?
So then would your answer be x equals 2 or x equals -2?
Yes, exactly. And you can write it either separately or you can write it just like this. This is legal right here. That says x is equal to, yeah, that says x equals +2 or -2.
2 equals +2. Also, it can't be 0.
What?
The x has to equal positive 2, else it
But
can't be
negative 2
0.
plus times negative 2 is 4.
No, I said plus.
We're not.
But it's
Wait a
okay.
minute, I'm
What?
so confused. Where
Never
is-
mind. Never mind.
Either way
I'm
works.
just talking about
Oh.
something else.
Oh, okay.
Apparently.
All right.
All confused.
Apparently, I'm talking
So,
about something else.
Let's just remember what we did though. Factoring the difference of 2 squares. Is everybody clear on factoring the difference of 2 squares?
Oh!
Fist of 5, I want to see. Awesome. Beautiful. All right.
Oh no.
So I'm going to give you your homework. We're done with the lecture.
Yeah.